Hello, everyone. I am Ravi Desai, SCR's Chief Engineer for the 2022-2023 project for Shasta the Sixth. I'm joined by Ariba and Leo, the two analysis co-leads for this year. Today, we're going to be walking through the flight simulations that the team has now decided to utilize and believes to be the most accurate in the team's history, at least on commercially available software or non-SRAD software, I suppose. So yeah, we'll get right into it. First, we're going to start off with the OpenRocket file of Shasta this year. This is the most up-to-date OpenRocket that we have. It's important to ensure that all weights, especially of recovery and their various components, such as shock cords, quick links, which have kind of been grouped into this miscellaneous recovery. There's CO2 cartridges, if they're still using that at this point in the future. But all their components are weighed out and organized and packed how they would be during launch, and that's represented correctly in OpenRocket. For this method of flight simulations, OpenRocket will only be utilized for gathering its center of gravity value and its distance from the nose cone tip down the rocket. So we want to use this value to then plug into RasAero. So assuming that you have a fully fledged out OpenRocket model with a correct CG, I would definitely recommend overriding all these components and actually weighing them out yourself so that you get the most accurate center of gravity and representation of your rocket overall. So you can see Shasta weighs 71.6 pounds and its center of gravity is at roughly 78.53 inches from the tip of the nose cone downwards. So now that we know that value, we can move to the next step. And that will be going into RasAero. Actually, before you do that, you also want to ensure that you save your OpenRocket file as a RockSim file. We will be utilizing OpenRocket, RasAero 2, and RockSim Pro preferably for the most accurate simulations. So the way you can save an OpenRocket as a RockSim is to go to File, export as, and select RockSim and save it as a RockSim file. So make sure you do that once your OpenRocket is fully finished. So then we'll move on to RasAero. And RasAero is going to be utilized to provide us with a table of coefficient of drags that we can gather and then input into RockSim Pro. So the reason why we're utilizing so many different softwares is because OpenRocket's flight simulations do not have the most accurate C sub D calculations, and it has been known in the team's history for OpenRocket to commonly overshoot a lot of our apogees. So I think starting from like Oberon's first launch and maybe even Prometheus, but definitely with Oberon in 2021 when they conducted a test launch at the South site and their other launch at Texas Shootout, and for Zenith's launch at Spaceport in 2022. For all three of those flights, OpenRocket has overshot or overpredicted the apogee, and we've fallen usually well below what it predicts by a good few thousand feet. So RasAero is highly advantageous to grab its C sub D calculations for two reasons. One, because it provides it, you can export it as a CSV or text file, and it calculates your C sub D every 0.001 seconds. And it is also built on a lot of, I think, previous missile and military data. So I think it's the only software that actually utilizes past flight data to influence its current calculations, whereas OpenRocket just uses flight equations. So it is much more accurate in that sense because it utilizes that real world data. So once you download RasAero 2, which is free, you can open up your RasAero file. So you'll also have to build your rocket in RasAero. Luckily, we can skip over that and open what we have already. So I'll go ahead and open our tech report file. And as you can see, this is Shasta. You can see that it calculates its own center of pressure, which is ultimately very similar to OpenRocket, and it represents the CG here as well. So from here, we will want to input or manually input the CG location. So we'll go to Flight Sim. Yeah, let me make this clear. So once you have your sorry, my computer likes to freeze. But once you have your model rocket loaded into RasAero, which is should be the same exact geometry as your OpenRocket file, you'll head over to flight simulation. The first time you do this, I think you'll have to select a motor, which I think comes up all on this screen. So you can select a motor. It should have every motor available that you would consider, every COPS motor. And then you'll have to manually input your nozzle exit diameter, which you can find online with all these COPS motors. But here's the most important part. You're going to manually input the CG from OpenRocket into RasAero. So 78.528 as the center of gravity calculated by OpenRocket. We're going to put it in a 78.53 on RasAero. And then the weight of the rocket is also 71.6 pounds. So we'll also put that into RasAero. So we can save that. And then we are going to run this simulation. So it ran, I didn't change anything from the last time I did this, so that's why none of the values updated. But once that is complete, I think you can, you'll scroll all the way to the end and view data. This will give you a nice plot of your altitude versus time, show you the parabolic path that our rocket will take throughout flight. But the main thing that we want is all of this data that RasAero luckily provides for us based off of its simulation. So we will go ahead and export that data to a CSV file, which I'm not going to do because we already have it downloaded, but in an instance that you're doing this for the first time, you would export it as a CSV file. You will then open that up as a CSV in Excel or any program of your choice. And you'll see that you're filled with a bunch of data. The only data that you will need for RockSim Pro is going to be this CD column. So all of these is the coefficient of drag of the rocket at this corresponding time. I think you also need the time column, sorry. So you'll need the time column and the CD column. You can just get rid and delete everything else, or sorry, not time. You'll need the Mach number and CD column. So you can delete all these other columns, get rid of them, and then you'll be left with the Mach number and the CD. That'll just make it easier to view and you don't have to be clouded by all these numbers. But once you do that, you can save it as a .txt file. And that's what has been done here. So you can see the Mach number on the left and the CD number on the right. It's actually easier to keep it within Excel, and you'll see why with RockSim Pro. But at this point now, we have utilized OpenRocket for its center of gravity. We've taken that center of gravity and we put it into RasAero 2. RasAero 2 then ran its own flight sims and provided us with the rocket's Mach number and its corresponding coefficient of drag at that Mach number and technically at that time as well. So now these two columns are the most important pieces of information that we will need for a very accurate RockSim Pro simulation. So RockSim Pro does cost $30 a month, which is a little pricey. Hopefully, by the time you are watching this video, SCR has received an influx of funding that allows you to not pay for RockSim Pro on your own. So I hope we are up there in the clouds. Anyways, let's go ahead and open the RockSim file, which we previously saved from that OpenRocket, which I have already saved here. So we can open that up. RockSim always, whenever you open a file, for whatever reason, does not load it in with your current motor. So you can add in your motor. You can see our stability right now is nearly 8, which is crazy. Obviously, we're closer to 2 in real life, and that's because the motor is not in. So you'll come over to this tab in the top left, which is Prepare for Launch, right next to the actual launch button. So open that up. You can see a number of tabs up here, which we will get into. But you're going to want to load in your correct motor, your correct engine. So for Shasta, we are using the O3400. So we'll load that in. You can right away press launch, and that'll just run the simulation right away. But for now, we will press OK. You can see the stability margin is at 2. A very important note, if you are doing this for the first time and you're loading in your RockSim file that you've saved from OpenRocket into RockSim Pro or even just regular RockSim for the first time, you'll notice that your stability will be way off. And that is because whenever you're importing from OpenRocket to RockSim, all of your components, their masses are correct and their mass overrides are correct, but you'll see that their center of gravity is set at 0. So for all of these components, when it's initially loaded in, you'll need to go through each component and manually input its own center of gravity. So for all of these, I assumed every component center of gravity to be in the middle. It would be most accurate technically if you were able to determine the CG of every component physically. So feel free to do that and you'll get a much more accurate CG. For now, the difference between a 1.97 stability from OpenRocket and a 2 stability on RockSim was deemed to be negligible and not worth the effort of finding the CG for every component. So the CG is at the middle of every weight component in this file. So you will have to manually go through and input that, which is a little bit of a pain, but is worth it in the end. So now with RockSim Pro, you'll go back to the prepare for launch and kind of run through the steps there. So I'm going to pull up the simulation that was already here so we can go through that together. For flight events, this is key on RockSim Pro because I don't think it's on regular RockSim, but we need to input our drogue and main parachute deployment. So for the drogue, we will tell it to deploy at apogee. So you can see all of these different criteria of where you want where you want the drogue to deploy. So you can input a Mach number at which if the rocket hits it, it'll deploy your drogue, and input a time, which is pretty cool. But obviously, we're going to deploy our drogue at apogee. And then we want our main parachute to deploy at 1,000 feet. That's what we have decided for the past few years and what we've gone with. So the way you do that is by, I think when you first open up RockSim Pro for the first time, it will only be one column or one row. So you'll have to add a row. In the first row, you'll put in apogee, and then you'll leave it as this. Or whatever it calculates for apogee. And then on the next row over, you're going to say deploy at an altitude less than 1,000 feet. So once your rocket is going in the air, first it has to hit its apogee, and then on the way down, as the moment your altitude is below 1,000 feet, your main parachute will deploy. I believe on this simulation, I can't figure it out for some reason, but our main parachute isn't deploying. So hopefully you have figured it out by then. But if you go on YouTube, there's a bunch of like help videos, I think explaining this a lot better than I did. So if you're a little more confused at this stage, then I would recommend checking out Apogee's video on how to do dual deployment on RockSim Pro, and they explain it pretty well. Next, your starting state. So this will be mainly specifying your launch rail length. For spaceport, our launch rail will be 17 feet. So we input it at that. The rest of these are kept at 0 or regular settings. Simulation controls, this should be checked if you're using this for the first time again. So you want to uncheck it and utilize, I think it was originally at 800 samples per second, but you want to do 1,000 samples per second. And then the CNA multiplier, CG multiplier, and CP offset, I think are the same, but make sure that they're set at 1, 1, and 0 respectively. As for the launch conditions, highly recommend that you input generally these numbers if you're trying to simulate a launch at Spaceport America. This is the altitude of the site. Relative landing zone altitude 700 was provided by Randy Merrick, the team mentor. Relative humidity, temperature, and pressure can all be found online. We're estimating around 105 degrees in the summer at launch at Spaceport. And then the coordinates of Spaceport America are right here as well. Now, next is the wind table. So this is a big component of RockSim Pro, and it allows you to gather a much more accurate simulation, especially if your wind direction and wind velocities are accurate per the site. So what we will be doing is inputting, luckily, Randy was kind enough to provide a wind table for us, which is based on data gathered at Spaceport, actually. So what you'll do is you'll go through and input, pretty much copy this exact same table into RockSim Pro. This will be found, or this can be found on SCR's drive under the analysis folder, under flight simulations for the 2022-2023 year. So hopefully you still have access to that and can pull this PowerPoint presentation up and get access to these wind tables. The RockSim Pro file should also be uploaded to the drive there as well if you want to pull up the drive and look at the actual RockSim file that we have utilized for this year. So long story short, you'll input all of those winds and their like the speed of the wind and the direction at which the wind is blowing at a certain altitude. And it's important to obviously cover all of the like if you're launching to try and go to 30,000 feet, you obviously want enough data to be able to say what the wind speeds are at those altitudes. So the big part of the wind table is that it allows you to calculate your smash plot for landing. So right now we're set at 20 uncertainty simulations. I would recommend copying all of these numbers utilized for uncertainty. These were also provided by Randy. Can't explain why he chose some of these numbers, but we're going to go with what he says. And I'm sure you can contact him. Hopefully he's still the team's mentor in the future. And you can ask for more in-depth explanations as to why these numbers were chosen in particular. Your number of uncertainty simulations is just how many times RockSim Pro is going to launch the rocket and simulate where it lands. So if you want a wider data set, obviously you can increase this number to 50 or 100, but keep in mind that it does take quite a while to run through all of the simulations. So one more thing to do before we can launch is to input the coefficient of drag table. So you'll uncheck this value, and then you will have to, unfortunately, manually enter all of the corresponding Mach numbers and CDs. You will have to pick and choose which, you'll have to pick and choose which Mach numbers and which CDs you'll want to input. I kind of went at it as your initial is just kind of at 0.01 or the moment at which you launch. So this one here, 0.01, 0.669 for the CD. So you can see that 0.01, 0.669. I then kind of just went up by 0.1 increments. So at 0.1 Mach, this is our CD. At 0.2 Mach, this is our CD, and so on and so forth, up into about our max Mach number, which per the RasAero simulation is 1.774. Then you're inputting your CDs, and then you can kind of drop it down, as you can imagine it coming back down after hitting apogee. So then I went to 1.6, and then I just went to 1, 0.5, 0.01, and then the final value for when our main is deployed was at 0.087 Mach and a 2.2 coefficient of drag, as that is the coefficient of drag of our main parachute. And 1.55 was the coefficient of drag of our drogue parachute. So you can see these last two entries at 23 and 24 were at drogue deployment and at main deployment. I'm not sure if this is the exact method used by Randy, but I do know that from his simulation versus my simulation, we ended up getting very similar apogees. So I'm quite confident in this method, but feel free to play around with it, see what maybe gives you better results. But this is what we have utilized for this year. So after all that, you can finally launch your rocket. So we'll go ahead and press launch, and you can see that it is going to run through all the uncertainties or the 20 different simulations that we set in that number of uncertainties, and it also estimates your time. So you can imagine it is pretty quick. Just through this time I'm talking, we're already at 15 out of 20, and we're done at 20. So obviously none of these numbers changed, but this is our prediction as of right now for Shasta. The advantage of these 20 simulations that it ran is this button here, plotting the landing points. So if we click that and then click the RockSim landing point chart, it will pull up this very nice plot. And this plot tells us two things. First, obviously, our launch point is at 0 miles, or this bottom part is the distance from the launch point. So our launch site or launch point, whatever, is at 0 and 0. You can see all of these blue dots were where RockSim projects the rocket to land, mainly based on your coefficient of drags and the wind table that you input, and how far that can land from the launch site. So it gathers or it runs all these simulations. These should be 20 different blue dots as to where the rocket landed with respect to the launch site. And this gray triangle is what you want to pay attention to, and that is what is the nominal landing point. So out of all of these simulations, RockSim projects that at around roughly 0.65, between 0.65 and 0.7 miles away from the launch site for Shasta to land. And that's a value that we have used in our technical report and also justification for our drogue chute size. But yeah, I think that is it. There's obviously a lot of things you can do with RockSim Pro. Looking at the graph, you can choose different axes to look at and look at more closely and pull that up. RockSim Pro lets you 3D visualize your launch, which is pretty cool. But yeah, this is the main purpose and the method that Space City Rocketry has used for its flight simulations for the 2022-2023 year for Shasta. So it will be good to check back, and maybe I'll make a separate video after we launch Shasta and compare our actual flight data to our simulated flight data, especially from RockSim Pro, as it is the first time that we are utilizing this data. So yeah, if you have any questions, try and find one of us somewhere in the future. I know I'll be around a little bit, but yeah, I know there's a lot of resources online to help you out as well. And the end all be all, hopefully Randy is still the team's mentor and you can talk to him and he'll be more than happy to share his method and walk you through it as well. Yeah, I think that'll be it for Space City Rocketry's flight sims for 2022 and 2023. Thank you for joining.